When you're adding an asset to the VNTANA platform, you have the ability to control your optimization settings. You can also control your optimization settings when you're editing an individual product or bulk editing your products. The first thing you're going to want to do is select where did the asset come from, and we call this pipelines. We optimize assets differently based on where they came from. Each program has its own quirks, so you're going to want to make sure you pick the correct pipeline here. Certain pipelines like convert only will do just that. All they're going to do is convert the asset to USDZ, FBX, and GLB. So you can use convert only if you don't want us to do anything to the asset. When assets run through the VNTANA optimization engine, we're first sanitizing them, and in that process, we're fixing flipped normals on the asset, we're fixing polygon windings, and we're just cleaning up a lot of maybe messiness that exists in the 3D file. We'll also remove a bunch of extraneous metadata that will bloat file size, but isn't actually going to change the way your asset looks visually. So let's first select where this came from. Let's say it came from Clo, for instance. Next, I'm going to come to my geometry optimization. So almost always you're going to want to have this on. The VNTANA intelligent optimization algorithm can automatically stop itself when it sees that it's over optimizing or over decimating an asset. So we recommend that you always keep geometry optimization on. We also usually recommend that you keep remove obstructed geometry on. What remove obstructed geometry does is it removes any geometry in the asset that is not visible. So picture an avatar that then is dressed. The avatar is a single mesh. Then you might have multiple meshes in the clothing that are overlaid on top of the avatar. What our remove obstructed geometry algorithm will do is it will actually remove any parts that are not visible, even if they're attached to other meshes. So for instance, with the avatar example, we would remove everything below the neck of the avatar, below the wrists, and above the ankles, but we'd still preserve the hands, the feet, and the head of the avatar. So it's really quite powerful, and we recommend keeping it on most of the time. Next, you can set your polygon limit. By default, we set our limit to 75,000. This is the target poly count that you're trying to hit. Again, as I mentioned, the intelligent optimization engine will actually stop itself if it can't achieve that target. So we have a bunch of safeguards built into the algorithm to stop it from over decimating. So 75,000 is a pretty good limit. That's why we have it as our default, but you can feel free to tweak that number based on what you need with your assets. Forced polygon limit will cause us to override many of the safeguards that we have in place to try and achieve that polygon count. If you're close, let's say you were at 100,000 and you're trying to get it to 75 or 50,000, you might be totally okay by using forced polygon limit. But if you're at 500,000 and you're trying to get to 50,000, you might run into some issues. We can't guarantee the quality every time when you click forced polygon limit, so we suggest that you play with it for your assets. Next, we have Draco compression. Draco compression reduces the amount of file size that the geometry data in your asset takes up in the overall file size of the asset. So we generally see that compress assets by 4 to 6x on the geometry side of things. So let's say if you had a 10 megabyte asset and the geometry was taking up 5 megabytes, we might expect that to be 1 megabyte of geometry and 5 megabytes of textures after applying Draco compression. It's very safe to have on. Technically it is lossy, but we recommend having Draco compression on if you're going to be embedding this in e-commerce, B2B, etc. If you're downloading an asset and uploading it somewhere else, it's possible they may not support Draco compression. In that case, you'll want to have it off. Shopify supports it, Snap supports it, but many other platforms do not. If you're going to be using the VNTANA viewer and embedding using VNTANA, we highly recommend you keep Draco compression on. Draco compression only applies to the GLB. So it only applies to GLTF, GLB assets. Next, we come to texture compression. So what texture compression does is it reduces the amount of file size that the textures are going to take up in your asset. The first thing you're going to want to think about with texture compression is your maximum resolution. Now, max resolution doesn't mean that we're atlasing all of your textures into a single 2K texture in this example. What it means is we're clamping the maximum resolution size for any individual texture. So if you're using a scanned asset, they might be 8K. In this case, we downres that to 2K. That's a simple example. Usually there's just a single material when you're using a 3D scan. However, with apparel assets or footwear assets, Oftentimes you have many materials, many textures, and so what this will do is clamp the maximum size of any one of those textures to 2K. We also offer 1K, 512, 4K, or unbounded. In the unbounded example, we're not going to clamp your texture size. The next thing that the algorithm does is that it will actually resize your textures based on a target texel density. So we will crop and resize those assets. Texel density is measured in pixels per meter. And basically, depending on the pipeline you've chosen right here, we have different target texel densities that are set. We also have the ability to customize pipelines. So if you think that it's not hitting the quality that you want, we can always change that target texel density on the back end for a given pipeline. So we resize and crop those textures, and then we'll convert all of those textures to JPEGs unless it's transparent, in which case we'll leave it as a GMP or PNG. And finally, we will compress the textures using regular JPEG compression. So this controls how aggressively you're going to compress those textures. So a 0 is just straight conversion, 1 is mild compression, and it goes on from there. Generally, you can get away with a 2 or a 3 without really noticing any difference in quality. If you go above that, you might see a little bit of degradation. If you have a black asset that's shiny, you might need to bring it down a little bit more. That's where you can really start to see some artifacts from compression. Two other things that you'll see here are KTX compression and bake ambient occlusion. KTX compression is a special type of compression that reduces the GPU footprint, the GPU memory that's required to process an asset. Where this can be really helpful is with browseware assets that might have many textures when you're exporting them. In that case, we'd recommend using KTX compression. Again, everything else works the same. It's just a different form of compression, and it will only apply right now to the GLB. It doesn't apply to USDZ or FBX. Then we have the bake ambient occlusion. So the optimization engine actually has the ability to bake an ambient occlusion map directly into your asset. Clo and browseware do not export with ambient occlusion maps, so using this will help enhance the realism of your asset. Ambient occlusion is kind of like the global shadows, the small shadowing you see in real life around the edges of things, not just the shadow that's cast by, the sun shining on a lamppost, for example. We recommend keeping texture compression on in almost all cases. If you need to improve the quality, feel free to up the resolution or bring down the aggression a little bit, but still you're going to want to keep it on. Textures are generally the biggest source of file size in 3D models. Next, we have 3D model scaling, and so we have the ability to scale your asset based on an individual axis. So we'll actually lock the axis. So let's say I had a couch and I uploaded it and the couch looked really small in augmented reality. What I can do here is say, hey, this couch is actually 2 meters wide. And so what we'll do is we'll resize that asset, and all of the processed assets, the GLB, the USDZ, and FBX, will now be the correct size. I can also change this to centimeters, meters, or inches if I want to. And this will allow your asset to look good in augmented reality the way that it should without you having to go back to a program. Down here we have pivot point alignment. Now this is usually used for virtual try-on cases, or Meta, for example, wants your assets to all be bottom centered. So we generally default to moving your pivot point to the center of the asset. We give you the option to do bottom center, or we cannot adjust it at all. That's totally up to you. So those are the main optimization settings that you can control. A final note is that our optimization engine is made up of about 30 to 40 different individual flags. So we have the ability to control a lot about the way that we optimize these assets. So if something isn't looking right or something doesn't seem it's not meeting your needs, please reach out to someone at VNTANA and we can probably create a custom pipeline for you very quickly just by changing the flags in the optimizer. Some examples of this are stopping merging meshes so we can preserve individual meshes if we wanted to do that, or compressing normal maps more aggressively than we compress diffuse maps, or really you'd probably want to do the opposite, but you get the point.